Hi, everyone. Thanks so much for joining in. I was asked by Hudson Library to give a presentation via Badger Talks. Badger Talks is a service of the University of Wisconsin-Madison, and it follows the notion that the boundaries of the university are the same as the boundaries of the state. And so when I heard that Hudson Library wanted somebody to come up on Earth Day of all days and talk about what can you do about climate change, I didn't hesitate. My name is Paul Stoy. I'm from Hudson. Dr. Bob Stoy is my father, Connie Stoy is my mother. And I wanted to go up to give this talk at a wonderful library, hang out with my folks, my brother Dave, and maybe grab dinner downtown on what I was hoping would be, just a lovely Earth Day, 50th anniversary of Earth Day. But things, of course, have changed quite a bit, right? We're in an international pandemic. We probably aren't doing what we were hoping to do on this wonderful day. And I have a picture of myself before quarantine, and my wife and kids are happy to let you know that my hair clippers will be arriving on Saturday, so I could be a bit more presentable. So thanks for joining into what I'm going to call the Hudson Virtual Library on this Earth Day to hear a talk about something that we should all hold very dear to our hearts, right? And that's not just the fact that Earth Day is for us, is that really Earth Day is in many ways of us. So Earth Day was founded by former US Senator, former US Governor, former Wisconsin State Senator Gaylord Nelson, the man from Clear Lake. And I was always just happy about the notion that Gaylord Nelson was from St. Croix River watershed. Then I thought about it a bit more deeply and said, hold it, actually, and I took a close look. Now, Clear Lake is in the Willow River watershed. So the headwaters of the mighty Willow are those lakes and streams and forests and fields that you will consistently hear about when reading and learning about Gaylord Nelson as his inspiration for creating Earth Day in the first place. And I'm posting below just the very most recent material that I found on this topic by his daughter, Tia Nelson, which goes quickly into Gaylord Nelson's childhood in Clear Lake and its importance. So, Earth Day is really a Polk County, St. Croix County thing in so many ways. And it's important to think about what we, as Northwestern Wisconsinites, could and should be doing to maintain this legacy now 50 years on. So, what's happened since the first Earth Day? Of course, global temperatures have increased quite a bit. So, by about a degree Celsius, right? We're talking almost 2 degrees Fahrenheit on average globally. This is a figure that I just found today by a climate scientist. And a lot of people have been noting that 2020 is shaping up to be, really on the warm side of even the past few years, perhaps. Now, this might not be your personal experience over the past few months of 2020, but it's true, it really is globally running a bit hot, and most of that warmth is in Eurasia. There have been, of course, a few notable cold events here in North America. Hasn't taken away from the fact when you're taking a global average, well, things are quite warm. Okay, it's always important to critique the data, so I went to a website from NASA today. You can see the URL right there below. Grabbed some data, made a quick plot, and you can see, quite clearly this approximate 1 degree Celsius increase from the 51 to 1980 base period when there's a relatively non-changing global temperature. So we're quite a lot warmer than we were 50 years ago in 1970 when Earth Day was first becoming a thing. So from all of this global temperature and global climate change stuff that you might hear about, it's just one equation. So global temperature is actually remarkably easy, and we solve it and we study it in class here at Wisconsin. The former university I was at for a decade, Montana State University. We just recently moved back to Madison. And the energy in the planet, just the energy coming in, has to equal the energy going out, plus or minus any changes in storage. So What changes the planetary energy balance? Now, these are quite a few things. This is a figure ultimately from Fosterdahl. This particular figure came from Scientific American, and this is changes since 1750. This is the anthropogenic era on the planetary energy balance. And you can see the largest thing causing a warming, that would be a positive radiative forcing. This is in watts per meter squared. That's a joule of energy per meter squared per second. Carbon dioxide, with a little bit of uncertainty, is the largest component of radiative forcing, but other things are extremely important as well. And many of these things are the things that we would like to tackle to improve our situation of increasing planetary and regional temperatures. So methane, for example, CH4, that is a large contributor to global change. Um, Hydrofluorocarbons, you can see in the halocarbon line, a number of other things, including soot, which is black carbon, especially when it falls on snow, which was bright until the soot came and then it turns dark and not so much energy is reflected back out into space. And there are some things that we know cool the planet and some things we still don't understand a lot about. One of those is that aerosol cloud interaction that has a negative radiative forcing of perhaps right half a watt per meter squared, which is right more than half of the radiative forcing of CO2 in the other direction. We actually don't know if that radiative forcing is on the order of 1 watt per meter squared or more, or if it's trivial, because some things in some parts of the Earth system we're still having a hard time understanding. And one of those is resolving clouds in models, estimating how long they hang around, understanding when they rain out, and some complicated aspects of clouds, like how the tall tropical clouds, the top of those things, because they're so cold, they're radiating less energy out into space, and they actually warm the planet. So clouds are quite tricky. We work on them a lot. The upside is we do know that quite a few of these compounds that warm the planet have some solutions that I'll talk about later in this presentation. So the other thing that we have going to our favor is the world is predominantly covered in oceans. Most of the heat that has been built up since in this figure is 1950 has gone into the ocean. So there's been a lot of ocean heating, right? The amount of heat entering the oceans is on the order of 10 to the 21st, 200 times 10 to the 21st joules. You might say, well, you just showed me some figures that were in watts per meter squared, which is a joule per meter squared per second. But the planet has, many meters squared, many square meters, and there's been many seconds since 1950 or 1750, as that previous figure showed. So the amount of heating in the land and atmosphere is a trivial amount of heating to the planet, but it's still important. It impacts our daily lives because we mostly live on land and our bodies are in the atmosphere. We're rarely in the oceans. So I'm arguing that global climate is actually quite simple. The hard thing is regional climates. Okay, a lot of energy is going into and out of regions. Things are swirling around in ways that we'd like to understand more. And a lot of what we do here in lab is ask kind of a simple question. When I was looking for materials to create presentations a few years ago, I stumbled on this one from Climate Central, which is a pretty reliable source for climate information. And this is showing trends in summer heat. This is in degrees Fahrenheit per decade since 1970, showing a large area of the Dakotas, perhaps Nebraska, Iowa, what have you, haven't actually increased in temperature. And this got me very interested because there's many reasons why that could be happening. There are some things that are happening simultaneously, and I apologize for this very busy figure. It's a graph from a paper by Rodell and others in 2018, where they're using a satellite called GRACE, which measures gravity. And from that, you can measure reasonably accurately groundwater, because water is quite heavy, showing that the northern Great Plains, this area mostly upwind of Wisconsin, has gotten a lot wetter over the past, in this case, it would be about 20 years. This figure is from 2002 to March of 2016. So why? What's happening? Upwind of Wisconsin, all these massive changes are occurring. And this is a quick paper that we just published this year showing once you add Canada, which is so important for really understanding the northern plains, especially in May and June, there's been a pronounced cooling of air temperature and an increase in precipitation, although that increase is mostly toward the eastern side of that study domain we've been working on, right, which we're calling the northern plains, outlined in black. So these are all interesting things. Why are these changes occurring? And might it also impact severe weather here in Wisconsin? So this is a image of a convective mesoscale system. So a mesoscale convective system, an MCS, a large one, right? These are thunderstorms the size of Wisconsin, if you will, that have been more frequent lately and have brought some dangerous conditions, including flooding, to much of Wisconsin, including western Wisconsin. For some reason, we don't know why, La Crosse and that area, the Kickapoo, have been hit particularly hard. So there's more water upwind of us, there's more energy in the system. We know that more energy means more mesoscale convective systems. And what we do in lab is we'd really like to know more about, will these trends continue and what are the mechanisms that underlie these regional climate processes? So we've been using climate models to figure out what's happening. All sorts of things could happen. Okay, there could be more cold air coming from the north. The surface is brighter with no-till agriculture. There's advection of moisture, especially with more irrigation in Nebraska over the past, in this case, 50 years. Other things happening with the circulation of the planet. There's a lot more vegetation in the northern plains than there used to be. And this is all fine and good, but this talk is fundamentally meant to be about, right, Hudson in northwestern Wisconsin. I think that this region is interesting and important because it is the part of the world that is usually upwind of the weather systems that hit us, but there's still a lot more that we'd like to know and are trying to figure out about Wisconsin and about Hudson. And most of what I was talking about was this period in late spring, early summer, whereas other seasons are warming about as much as you'd expect. And if you take a close look at that top figure, that figure in winter, this is a similar map from Climate Central, a slightly different period, which is why you have slightly different summertime, perhaps cooling trends in the northern plains. You see that in winter, we are really right in the bullseye of where things have gotten the most warm in the conterminous United States over the past 40 or 50 years. So we always have to critique these data sets. Here's another one from the Wisconsin Initiative on Climate Change Impacts. Currently, my friend and colleague Dan Vimont is one of the leaders of this organization. This is from 1950 to 2006, slightly different period. You see change in observed annual average temperature, and northwestern Wisconsin is getting warmer than much of the rest of the state. And that effect is particularly pronounced in winter. So again, this is degrees Fahrenheit in this figure. We're seeing, 4 or more, right, degrees Fahrenheit change in wintertime temperatures. That would be December, January, February is climatological winter. From 1950, this figure happens to be till 2006, but I can say with certainty, right, that growing up in Hudson in the 80s and 90s, that things are distinctly warmer now when I go visit home than they used to be. And I know that everybody who's listening in has probably more experience than I do on this critical topic that does impact our livelihoods. So the next question becomes, what should we do? There are all these things that need to happen globally that could and perhaps should happen globally. There are some parts of the climate system that we admittedly don't understand, and we'd like to understand more, but there have been some wonderful people studying how individuals and the globe can all come together and do a better job in becoming, right, in helping out our planet. So a lot of what people talk about and think about, including some of the work that we do in my laboratory, is the idea that ecosystems can store a lot of carbon because they do, right? Should we be doing a better job putting more carbon into our ecosystems? And really, what things should we be planting and what things should we be growing in order to help that carbon storage? And I came about this when, a friend from Hudson was asking, why are they restoring prairie when a forest would take up more carbon. And then I thought, well, actually, I think a prairie would take up more carbon. And this kind of holds over very long sort of century timescales. Okay, and there's also something very unique about Hudson. And so this is a figure I got from the DNR. And it is the General Land Office original land survey of Wisconsin, 1832 to 1886. And you can see over there, sort of St. Croix County, we have more prairie, native prairie, than much of the rest of the state of Wisconsin. And this is a cool opportunity, right? St. Croix County has wonderful ecology. All sorts of different things grow there. All sorts of different things used to grow there, including you'll see a lot of oak openings, bur oak, white oak, black oak. Those would be, well, there's also red oak. Those would be importantly the oak savanna that used to dominate across much of the state and is a wonderful ecosystem, also very difficult to restore. So zooming in a little bit here on St. Croix County, right, we have what used to grow there, at least in the mid 1800s, right? Is this the original vegetation? Is this what we want, especially when climate is continuously giving us a moving target with respect to what will grow best where? I would still argue that the tallgrass prairie that used to grow across much of St. Croix County is a wonderful option for individuals or groups to think about restoring if they want to have a carbon advantage. Why is that? Right, because perennial prairie grasses make enormous root systems and they store lots and lots of carbon underground. Why do we know this, right? Why might a prairie have more carbon, in fact, than a forest? Well, that's why when they plowed the Great Plains, they plowed prairie for that thick and rich and extremely deep topsoil, much of which unfortunately has been lost, and also, unfortunately, which takes a very long time to recover. So many times when you're looking, because humans are very visual creatures, and you see a forest and it looks like a lot of carbon there, a prairie, especially a native prairie, which doesn't barely exist, it's one of the world's most endangered ecosystems, as I mentioned, that might have more carbon simply underground. Okay, and there's a lot of caveats and there's a lot of challenges with these statements about how to best manage the landscape for carbon storage. But I would argue, especially in places where prairie is prone to grow in Hudson and St. Croix County, I would say go for it. That doesn't mean everywhere, right? Of course, as you're toward the St. Croix River, as you're toward the Willow River, a lot of other places, there's going to be forest, and that's great too. But don't discount the prairie if it comes to, right, restoring not just the carbon function of ecosystems, but also the biodiversity, of course, as well. So, a challenge with these quote unquote natural climate solutions is to avoid the quote unquote dangerous climate change, which is 1.5 degrees Celsius, so almost 3 degrees Fahrenheit, that was agreed upon at the Paris Agreement. That carbon is going to take quite a bit of time to accrue in the soils of prairies, right? Trees don't grow particularly fast around Hudson. That's not to say they don't grow, but they probably don't grow fast enough to have the emissions reductions in CO2 necessary to avoid what's called dangerous climate change. So what actually needs to be done, we need to reduce emissions approximately double every decade from 2020 to 2030, 2040 onward. Okay, we have to cut our CO2 emissions in half and at the same time drive CO2 emissions from land use, which is currently a carbon source to the atmosphere, mostly through tropical deforestation and the expansion of agriculture, while somehow actively removing carbon dioxide from the atmosphere. And this is a big ask. So, fortunately, right, people commit their lives to understanding these climate solutions. And the ones I'm going to bring about today come from Project Drawdown. So John Foley is currently the executive director. He was a faculty member here at the University of Wisconsin for a very long time. I was very fortunate to work in his laboratory when I was an undergraduate. Well, this would be back in the late 1990s. And happy to also say that John became a grandfather just yesterday. So with John's leadership and leadership of many people who work on Project Drawdown, they've provided a table of solutions. And so what I wanted to do shortly is go through these solutions for scenario 2. This is the 1.5 degrees Celsius global warming, and talk about, are they relevant to what we do day in and day out in Wisconsin and in Hudson? Or, well, perhaps is this a challenge for somebody else to tackle? So, number one, the top solution for drawing down carbon dioxide, right, changing our energy systems in a way that still provides energy for all of us, is onshore wind turbines. So expanding wind farms. As we know, right, there are not a lot of wind farms in St. Croix County. In fact, in Wisconsin, there's really, in my understanding, only a couple of nodes sort of toward Fond du Lac where there's the Niagara Escarpment, and that happens to be a slightly windier place in the world where making a wind turbine makes a lot more sense. Now, southern Minnesota, especially southwestern Minnesota, Iowa, a lot of places in the Great Plains have extensive wind development, and this is nice. A challenge with renewable energy as a whole in today's era is that there have been, unfortunately, a lot of layoffs in the renewable energy industries due to COVID-19. So I bring this up as well because one, a close friend of mine, Sam, is from Stillwater, who lives in Bozeman, where I used to live, was one of the people who installed this large solar array, which is the number 2 climate solution suggested by Drawdown: utility scale, so large scale solar photovoltaic systems. And also solution number 5 is distributed photovoltaics. Think things on your roof, right, or smaller photovoltaic systems. These are good solutions, and Hudson might not be the sunniest place in the world, but it's sunny enough that I think expanding solar panel development, either at more industrial scales or simply at local scales, would do quite a bit to productively change our energy infrastructure. There's some caveats to that, right? Heavy metals are involved in the creation of solar panels. There's the cost of installing them in the first place, which is usually paid off, of course, over some time. But these are the things, the technology exists, and they can do quite a bit to change our energy infrastructure and reduce our global carbon footprint. So solutions 3 and 4, these are ranked in order of importance, are reduced food waste and also plant-rich diets. And I intentionally have the same figure from Politico.com that I found just today of the problem, which is that there is a massive disruption of supply chains, also for food, due to COVID-19. And I know that a lot of people here have seen probably more stories than I have about discarding crops, right? And people who simply can't bring their product to market, which has been increasing food waste, which is a big tragedy. But also people are making, right now that everybody's stuck at home, perhaps more individual decisions about what they eat, right? Running around less, going out to eat certainly less, with the opportunity to perhaps, should you choose, have a more plant-rich diet and avoid some of the inefficiencies of a heavily meat-rich diet that come from the fact that it takes a lot of land and other things and energy to produce meat. That's not to say everybody should go vegetarian right away, right? But replacing some meat with more plants in your diet, as I'm sure my dad would say as well, okay, is a nice way to live a healthier lifestyle. So don't necessarily go vegan right away, but the more that you can replace meat with plants in your diet and especially reduce food waste, these are meaningful, positive steps that we can all take, myself included, to improve the health of the planet and ourselves. So numbers 5, 6, and 7 are mostly topics for tropical countries. And this involves, right, health and education and the ability of people to make their own choices about how they live their lives, restoring tropical forests. And this isn't something we think about every day, but a lot of soot comes from cook stoves in developing countries that emit a lot of particulates. So improving clean cook stoves is one of the biggest steps in helping people do that, to have healthier indoor and outdoor air quality, and also to reduce global climate change, surprisingly. So I want to point these things out because they are important, right? Billions of people rely on cook stoves, And with with assistance, with encouragement, with infrastructure and resources, we can help solve these challenges to global climate that help in so many ways, right? Individual health as well. So numbers 9 and 10 on Project Drawdown list are refrigerant, and I apologize, I might have misspelled that, management and alternate refrigerants. Why is that? So these fluorocarbons that are used as refrigerants are enormous contributions of the CFCs toward positive radiative forcing toward global warming. A challenge emerges when a hotter temperature means that we need more refrigerants, more air conditioners, which means that our refrigerators need to do more work to keep things cool. But solutions exist, right? We don't have to be using fluorinated fluorocarbons to cool things necessarily, but doing so is going to take a bit of work. The other top 14 here solutions listed in Project Drawdown are a few things that may or may not be relevant to St. Croix County. Silvopasture, right? This is rangelands inside of forests, right? This might be something that we can do while simultaneously restoring some of the oak savannas, beautiful oak savannas that used to be in St. Croix County and surrounds. I've heard the argument recently that people don't think you can successfully restore a oak savanna without the presence of large ungulates like bison, which would certainly be a cool thing to do. Another thing that is extremely important is protecting the carbon stored in peatlands. So I'm going to say that these wetlands that you see, and this is an old map that I found online of land use in St. Croix, the Willow River watershed. There are some wetlands, right? There are some places that should best be protected to help keep the carbon in the ground. And they list tree plantations on degraded land. Now, this might be a solution, especially in places where trees formerly grew, might positively impact, right? St. Croix Valley. I'm not entirely sure. I wouldn't be against the idea. And something that we could do quite a bit of, given the amount of cropland in Hudson's surrounds, is encourage the growth of perennial staple crops. So these are tricky things like Kernza, the efforts to make annual crops into perennials for the purpose of improving soil carbon storage and soil fertility. Right? Conventional agriculture is very energy intensive. Right? Annual crops need to be planted all the time. If those things can already be in the ground, yet give us the same amount of seed, and there's reasons why perennials don't do that, we could actually be getting things that we eat while doing the best for our soils at the same time. So I found this somewhat old map of land use in the Willow River watershed, and that got me thinking about, right, there is a substantial amount of what is considered, at least by these people who made this map, Allmendigger and others, quite a few years ago now, that are in grassland. Right? There's quite a few areas in forest, a lot of cropland, as we know. And together, I think that we can work on improving this landscape to store more carbon, make the same amount of money as before, hopefully. And people here at the University of Wisconsin are very active in trying to have transitions in land use toward more sustainable systems. So the message, of course, is always, humans are a central part of the Earth system. It is absolutely our job to do the best that we can for our planet, and there are many existing solutions that can get us well on our way. So we'll take a turn back to Senator Nelson and ask the question, right? We have this beautiful landscape in northwestern Wisconsin. We have all of these things that we value. And on Earth Day, right, which is part of something, is part of us, is part of what we should be doing, we should all take one more step back and think, even in our new era, can we, after this is all said and done with COVID, have an energy system, have a planet that works not just for people, but also everything else on the planet as well. So thank you so much for your time and attention, and please do not hesitate to email me if you have any questions.